Picture this. Every time you look up at the night sky, you're staring at a minefield. That's low Earth orbit, LEO, a region so crowded with high-speed debris that it's become one of humanity's riskiest frontiers. Since the start of the space age, we've launched over 50,000 tons of material into orbit, leaving behind a toxic ring of metallic trash. Dead satellites, spent rocket stages, and millions of fragments from explosions and collisions. These shards, some smaller than a paint fleck, zip around at up to 27,000 kilometers per hour, fast enough for even the tiniest piece to destroy a spacecraft. This relentless buildup has pushed us to the edge of the density threshold, where random collisions aren't rare. They're inevitable. This is the Kessler bottleneck, a tipping point where one collision sparks a chain reaction, creating a self-sustaining storm of debris that could lock us out of space for generations. The Kessler syndrome, first predicted in 1978, describes this exact cascade. When two objects collide, they shatter into thousands of new fragments, each one a bullet waiting to strike something else. The 2009 Iridium Cosmos collision is a textbook case. A defunct Russian satellite and a working American one smashed together, instantly generating thousands of trackable fragments. Each new piece raised the odds of another collision. If this cascade continues unchecked, we risk losing access to the orbital highways that power GPS, global communications, weather forecasting, and military intelligence. The loss of LEO wouldn't just be inconvenient, it would be a global crisis, paralyzing the systems we rely on and trapping humanity on Earth. So, how do we clean up this orbital minefield? Enter active debris removal, or ADR. For the biggest threats, large, dead satellites and rocket bodies, engineers are developing robotic arms and harpoons to capture and deorbit them, burning them up safely in the atmosphere. For smaller fragments, there's electrodynamic tethers, long wires that use Earth's magnetic field to drag debris down, or laser nudging, where a focused laser pulse gives a tiny push, slowly lowering the fragment's orbit. The immediate goal? Remove the top 50 riskiest objects to prevent a catastrophic chain reaction. But here's the catch. Every piece of debris belongs to the country that launched it, and there's no global law forcing anyone to clean up. Who pays to remove a derelict Russian satellite or a shattered Chinese rocket body? Cleanup is expensive, but NASA studies show the cost is far outweighed by the risk reduction within a decade. The only way forward is international collaboration, setting standards for new satellites and creating a global fund to finance the cleanup. The minefield above us is real, but with urgency and cooperation, it's a challenge we can defuse.